This is the test review for the trig problems. I don't want to be too specific about the problem numbers because over different semesters, sometimes the reviews change, so I want to just work these problems out and then be able to place them wherever I want. So just so you know that the review you're working on obviously will have the problems numbered, but I'm not going to refer to numbers here. So in the future, I can be flexible with making these videos available to my classes. So this test review is really for the initial topics that we cover in MATH137 in our trig class. First thing we do is a bunch of work with angles. Now what I will do is I will work some problems out, and as I'm working the problems, I will take a minute or two and explain what we're doing. So along with just working out the problem, hopefully reminding and even teaching why we do what we do. So for instance, the first couple problems deal with how we express angles. And first of all, there's two ways that we express or measure angles. And that's in degrees, but also radians. And in a minute, we're going to do some problems where we look at angles both in degrees and radians and convert back and forth. And throughout the rest of this class, sometimes we will have problems with angles in degrees and sometimes with angles in radians. But within the degree world, there's also two different ways to express those angles. And the first, you can express an angle as a decimal. For example, 47.1 degrees. But you can also express the angle in what we call degrees, minutes, seconds, where you say 41 degrees, 25 minutes, 10 seconds. Right? So this stands for degrees, this is minutes, and this is seconds. It's interesting how with these angles, they use the words minutes and seconds, just like time, and the numbers are actually the same because 1 degree equals 60 minutes, and then 1 minute equals 60 seconds. All right, so based upon all this stuff, now we're going to actually try and convert decimals to degrees, minutes, seconds, and degrees, minutes, seconds to decimal. So the first problem, we're given an angle, and we're told the angle is 80 degrees, 23 minutes. Actually, let me do a second problem because it has degrees, minutes, seconds. So actually I'm going to do an angle that's 120 degrees, 20 minutes, and 50 seconds. I want to rewrite this angle as a decimal in degrees. Now the thing you need to understand, when we convert back and forth, the degrees part of this number is not going to change. In other words, when I get my answer over here, it's going to be 120 point something. This 20 minutes and 50 seconds is what we call the decimal part. This is what I have to convert to a decimal that's going to go over here. All right, so the way that I do that is I first start with my seconds, and I'm going to convert 50 seconds into minutes. And to do that, I use our unit fraction. Since my since my units are minutes here, minutes are in the bottom. Sorry, seconds here, seconds in the bottom. I want to convert 50 seconds into minutes, so minutes go on the top. Now I say, what's the relationship between seconds and minutes? There's 60 seconds in 1 minute. So now I grab my calculator, and I have 50 times 1 divided by 60. So basically 50 divided by 60, 0.833. I'll just round it off to 3 digits here. So 50 seconds is the same thing as 0.833 minutes. Now I'm going to take this 0.833 minutes and add it to the minutes part of my original angle. So now I'm going to have 20.833 minutes, right? Since I converted 50 seconds into 0.833 minutes, this whole thing is 20.833 minutes. However, I want to convert this into degrees. So I start with minutes. Minutes go on the bottom, degrees are on the top. The relationship is 16 minutes and 1 degree. So now I have 20.833 times 1 divided by 60. And that ends up equaling, I'll just round it to maybe two digits, or maybe 3. 0.347 degrees. So now this right here is the decimal part of our original angle. So then I can say, or let's write it down here, 120.347 degrees. All right, hopefully not too hard. So once again, you take the seconds part, you convert it to minutes. You take that minutes, add it to your original minutes, convert that new minutes number into degrees, and then that's the decimal part of your answer. Now let's go the other way. Let's take a angle that's given to us in degrees, and we want to know what is it going to be in degrees, minutes, seconds. So once again, what we're really dealing with, basically I have to take the decimal part of this number and convert that into minutes and seconds. Because the degrees, the whole number part of this is not going to change. So when I do my final answer here, I know right away the degrees part is going to be 123 degrees. Now I have to figure out, convert 0.123 degrees and see how many minutes and seconds that is. So let me go ahead and get a new sheet of paper so I have room to finish this. So basically, I'm taking 0.123 degrees, and the first thing I'm going to do is convert 0.123 degrees into minutes. So if I have degrees here, degrees in the bottom, minutes in the top, I say, what's the relationship between minutes and degrees? 60 minutes and 1 degree. So now I can multiply 0.123 times 60. 7.38 minutes. So 0.123 degrees is the same thing as 7.38 minutes. Now here's what I'm going to do. I'm going to grab the whole part of this number, and that's going to become the minutes number for my final answer. So here I've got 7.38. So I'm going to take 7 minutes, and I'm going to go back here. I know 123 degrees. Now I know I'm going to have 7 minutes. And now what I'm going to do is take the 0.38 minutes and convert that into seconds. And that'll be the number of seconds in my final answer. So now 0.38 minutes. I want to convert it to seconds. Minutes on the top, minutes on the bottom, seconds on the top. What's the relationship? 60 seconds and 1 minute. So you take 0.38 times 60, 22.8 seconds, which we're going to round off to 23 seconds. So 0.38 minutes is approximately 23 seconds. So that becomes the seconds part of my final answer. So I go back here, and now I realize we have 23 seconds. So 123.123 degrees is the same thing as 123 degrees, 7 minutes, 23 seconds. All right, so that's a couple of problems. I'm converting back and forth between decimal degrees and degrees a minute seconds. Now the next kind of problem we have is converting back and forth between degrees and radians, right? So I said really, throughout this class, sometimes some problems will have the angle expressed in degrees, and sometimes the angle is in radians. And now we're going to look, how do you convert back and forth? If we have an angle in degrees, we might be asked, or we might need to convert it to radians. And there will be other times when we're given it an angle in radians and we need to convert it to degrees, so we go back and forth. Now the whole key to this relationship is to realize, and I don't have time to explain it now, but I explained it in class, is that 180 degrees is the same thing as pi. Now let me write radians here, but just so you know, if an angle is expressed in radians, radians is not really a unit that we write. So for example, that angle, there's a 47-degree angle for theta. But if you ever see this, theta equals 4, what that really means is 4 radians. If the little degree symbol's not there, then you know that the angle is actually in radians. Now, a lot of times in this class, a lot of times in radians, you'll always see this pi here. That's sort of a little bit of a dead giveaway that the number's in radians, but not always. Now, when I work out these problems, sometimes I write radians here just to make it clear what's going on, but just be aware that normally when you have an angle in radians, you will not see the word radians. All right, so here's a problem. we need to convert, or we ask how many radians is a 126 degree angle. So basically we're going to convert 126 degrees into radians. Pretty straightforward. You use the principle of unit fractions just like we do in math whenever you want to convert fractions. So I start with degrees. Degrees go on the bottom. I'm trying to get to radians, so I'll go ahead and put radians up on the top. And then I say, what's the relationship between degrees and radians? Well, we know there's pi radians and 180 degrees. And now here's an important principle we start talking about. A lot of times in the world of trig, they will ask you to give exact answers. One sort of rule of thumb that is almost always true is when they ask for exact answers, you can think of it as saying they don't want you to really use your calculator. You're not going to, for instance here, we have this pi here. Of course, pi is 3.1415 and it goes on forever. If you try to use your calculator, it's going to have to at some point round off your numbers to get an answer. Well, we don't want to have to round anything. So if we just leave the pi as it is, that's considered an exact answer. So to do this, I'm not going to just go grab my calculator and do this calculation. Matter of fact, I'm just going to see if things reduce, the number's reduced, and then leave it whatever I get left. So here, 126 over 180 looks like 2 goes into both of them, so I divide both of them by 2 to reduce. This is like 64. This is 90. Oh, not 64, 63, sorry. And then I notice 63 and 90, I have a common factor of 9. So let's divide top and the bottom by 9. And you got 7/10. And at this point, the numbers are not going to reduce anymore. So basically you get 7 pi over 10. So 126 degree angle is 7 pi over 10, or sometimes you can see this written, sometimes I write it 7/10 pi. Once again, those are both the same. All right, not too bad. Now let's go the other way. How about if we were asked, here's an angle in radians, and we want to convert it to degrees. Well, the nice thing is the method's the same as what we just did. You still do your unit fraction. So you start with your initial angle in radians. Radians on the top, so radians are going to be in the bottom of my fraction. Degrees are in the top. Relationship between degrees and radians, there's 180 degrees in pi radians. So once again, we're going to get an exact answer, so I'm not going to use my calculator unless the numbers get too big, I need some help. But hopefully I can just do these in my head with some canceling. First of all, look at this. I got a pi in the top as a factor and a pi in the bottom as a factor. The pi's cancel out. I notice I got 180 up here and 3 here. Now in my head I realize that 3 goes into 180. 60 times 3 is 180. So if I divide the top and the bottom by 3, I'm left with 60 and 1. So now 2 times 60. So basically a 2 pi over 3 angle in radians equals 120 degrees. Now let me do a couple more problems converting, and this will also be a chance to talk a little bit about how measuring these angles work. Because the next problem I see wants me to convert a 9 pi angle into degrees. Now, I'm not going to take the time to explain in a lot of detail, but basically, hopefully you remember from class that a lot of times when we look at angles, we like to use the X and Y axis, and the starting point almost every time when we have an angle is the X axis. And then as you move in the counterclockwise direction, that's considered a positive angle. So if I go from here to here, that's a 90-degree angle, and then 180 straight across. Down here is 370. When I get back to here, this is actually a 360-degree angle. I've gone all the way around. And the point is, sometimes you can keep going. So in other words, if I go here and stop, what is this angle? Well, it's 360 plus 90 more. This is actually a 450-degree angle. And the same thing goes for pi and for radians. Now actually, if you start here, if you go up to here, you've gone pi over 2 radians. If you go halfway across, you've gone pi. If you go all the way across, you've gone 2 pi. So if I was to look at this angle, I've gone pi over 2 more. So 2 pi plus pi over 2. Now sometimes in this class, you've got to remember some of your algebra and even just adding, subtracting fractions. 2 pi is the same thing as 4 pi over 2 plus pi over 2. Looks like this angle can also be expressed as 5 pi over 2 radians. So I take a minute to talk about that because look at the angle we're looking at. 9 pi. So actually, if you go all the way around the circle in 2 pi, then here we're actually going around the circle many times. And what you have to do is you have to sort of reduce this number until where it's less than 2 pi. That's usually the easiest way to do these problems. Oh, I'm misspeaking. Actually, we don't want to reduce it. We want to just go ahead and determine this degrees. Let me show you this. We want to see how many degrees is. But the idea about explaining this is, I know 9 degrees is going to be going around and around many times. So it's going to be 360 plus 360 plus, that's what's going on here when you see an angle like 9 pi. So for this problem, I actually want to convert 9 pi's to degrees. So I think this degrees number is going to be a pretty big number. So let's go ahead and do our normal. Convert 9 pi radians into degrees. So start with radians, radians on the bottom, degrees on the top. Pi radians. 180 degrees. Once again, the pi's cancel out. So you're left with 9 times 180. And if I do it in my head, I'm not incorrect. It's probably 900 plus 720. Let's see, I've got the answers here. Let's see if I did the math in my head correctly. I think it's like 1620, which is actually correct. Says 360 is one trip around. You can see we have to go like around maybe 3 or 4 times, just like with 9 pi. And then the last one of these, which let me go and do it just because it gives us a chance to explain another important principle that's important to know. They wanted you to convert negative 5 pi over 2 into degrees. So what's it mean when you have like a negative angle? When I explained angles a minute ago, I said we start the x-axis, and as you move up here in the counterclockwise direction, like that's 90 degrees or pi over 2 radians. So what would it mean if we have a negative angle? That means you move the opposite direction. You sort of move clockwise. So this angle here would be negative 90 degrees or negative pi over 2. So just so you know, we can go ahead and convert this angle in radians to degrees just mathematically. But once again, I wanted to take the chance to just review for you quickly what it means when we have a negative angle. So let's go ahead and convert this negative 5 pi over 2 radians into degrees. So here's our unit fraction again. Start with radians, radians on the bottom, degrees on the top. The relationship is 180 degrees in pi radians. So now, since we want an exact answer, the pi's cancel out. I know I've got 180 degrees up here and 2 on the bottom. That reduces down to 90. So I've got minus 5 times 90, which is negative 450 degrees. All right, not too bad, hopefully. So let me stop now, and I'll start the next video, and then we'll look at some more other kinds of special angle problems.